Hi everyone, welcome back to another day of notes. Today we're going to be talking about transformations with linear functions. So let's talk about family of functions. A family of functions is just a group of functions with the same characteristics. We're going to be talking about linear today. So all of these functions that we're talking about are going to create lines. A parent function is the simplest function with these characteristics. So for example, the linear parent function is an x and a y. So those are the only two requirements that you need for a linear equation. You need to have the x, you need to have the y. Sometimes you have a b, sometimes you don't. It's not like written in. Sometimes you have a slope written in, sometimes you don't have it in. It's not a requirement because when those numbers are missing, we know what they are. They're those invisible numbers. Okay? But you have to have the letter y and the letter x in there. Okay? So we are going to go ahead and graph the parent function of a linear equation in a black line. So I suggest if you have colored pencils, crayons, markers, colored pens, I think it's really beneficial if you do it in different colors so you can see exactly what's happening when you draw these different lines. If you don't, it's not a big deal because you can watch the screen and see what's going on. Okay? But you do need to graph these lines. So we're going to start with graphing that parent function y equals x. So when y equals x, it has a slope of 1 and a y-intercept of 0. Those are the invisible numbers we were talking about. So I'm going to start with the y-intercept, then I go up 1 to the right, up 1 to the right, up 1 to the right, and it's eventually going to create, not that line. Oh no, that's not what I wanted to happen. Let me go back. I want it to create this line, okay? This is the graph of the parent function, where it's just a straight diagonal line going through the middle of the graph. Okay, goes through the origin, just slope going is a positive 1. Now we're going to graph the line y equals negative x in pink. So this time the y-intercept is still 0, but now the slope is a negative 1. So I'm going to start at the origin, and I'm going to go down 1 to the right, down 1 to the right, down 1 to the right, and it will create this line. What's the difference between the black and the pink line now? Well, the pink line is going in the opposite direction. Okay, so it's kind of flipped. All right, so that negative for the slope really changes the direction that the line's heading in. All right, now we're going to graph the line y equals negative 3 in red, and we're going to graph y equals x plus 5 in blue. So y equals x minus 3 means we have a negative 3 for our y-intercept, and the slope is still positive 1. So I start at negative 3, I'm going to go up 1, over 1 to create my red line. Maybe. There we go. That creates my red line. And I go ahead and do the same thing, but now my y-intercept is positive 5. So I go up to positive 5, and I go ahead and do rise over run a couple of times to get my slope in, and it creates this line. So how are the red and black lines different? Well, they have the same slope. The red line's just been moved down 3 units. So it's lower on the graph, and it went down 3 units. The blue line is higher on the graph by 5 units, so it just went up 5 units. So the red line went down 3, and the blue line went up 5. So that y-intercept tells you the shift in the line. Like I could have just shifted the black line up 5 units, I would have gotten the same line. Shifted it down 3 units, I would have gotten the same line. The y-intercept will tell you the shift. Okay? On your next page, we're going to regraph the parent function just because our graph was getting a little crowded. So, not that. Ah! So irritating. Okay. So here's my black line, which is my parent function. Okay? Now I'm going to graph the line y equals 1/2 x. So here, this has a y-intercept of 0 still, but it's got a slope of 1 over 2. So from the origin, I'm going to go up 1 over 2, and that creates my yellow line. In green, I'm going to do y equals 4x, and so that means my slope is now 4, my y-intercept is still 0, so I start at 0, I go up 4 over 1, to create my green line? Well, now I can answer these questions. How are the black and yellow lines different? Well, they're going in the same direction, but the yellow line's a little less steep. It's a little flatter than the black line. Okay? And then how are the black and green lines different? If we look at these two, the green is way steeper than the black line. So the slope actually influences the steepness. The bigger the number, the steeper the slope will be. Okay? Okay. There was more on this page. I'm so sorry. So translation is a vertical shift either up or down, and we look at the y-intercept to determine that. Okay? These are the different kinds of transformations we can have. We can have a translation, which is just shifting it up or down. Steepness, where if m is greater than 1, we say the line is steeper. If it's less than 1, we say it's less steep or flatter. And then reflection is if the slope is negative, we say it has a reflection. Okay? So, it's really easy to tell what's going on between two lines on a graph. It's not as easy to tell from an equation. But knowing this, the y-intercept, the slope, and if the slope is negative, can tell us about these transformations. I think reflection you had to write in, sorry. But in order to tell these things, we need it in slope-intercept form. So I'm going to first change this to slope-intercept form by subtracting x from both sides. So now we have the equation, y equals negative 1x plus 9. Okay? The negative sign tells me there's a reflection. The slope is 1, so just because the number is 1, it's going to be the same steepness. So slope equals 1, so same steepness. Okay, so the number of the slope tells us about the steepness. Okay, there we go. And then the y-intercept tells me that it's a vertical shift up 9 units from the parent function. So that's what I would write as my final answer. I would just say reflection. Ooh, I'm just writing a bunch of letters. Reflection, same steepness, and shifted up 9 units. Okay? And that would be my answer if it asked me to describe the transformation. It's a reflection, the same steepness, and shifted up 9 units. Okay? So I literally just check off each kind of transformation and talk about it. So you guys are going to try these two on your own. This one, you're going to have to change the slope-intercept form first. Okay? But if you have any questions, write them down, and I'll be happy to answer them next class. Okay? Bye.